So let's do a few examples of chain rule here. So chain rule, we're going to take the derivative of the outside and then multiply it by the derivative of the inside. So our outside here, if we try to identify this, is this parentheses cubed. So whatever's in our parentheses, that is our outside, so out. And then what's our inside? Well, that's 4x minus 1. So that's our n, right? So we're going to take the derivative of our outside, which is 3, and then whatever it's inside, and all that squared, multiplied by the derivative of our inside, which is just 4. So if we finalize this, this is 3 times 4x minus 1 squared times 4, so we can just simplify that to 12 times 4x minus 1 squared. So let's do our second example here. So over here we have 2 plus, and then parentheses, x squared plus 1 to the 4th, and then an all cubed. So our first outside here is this big parentheses, and that's cubed, right? So that's our out number 1. And then inside of here, it looks like we're going to have to use chain rule again. So our second out is 2 plus, and then whatever's in this parentheses to the 4th. So this is out number 2. And then looks like inside of our to the 4th, we have an x squared plus 1. So that's our final inside, right? So if we take the derivative of this, we have 3 to whatever is inside of it squared multiplied by, and then the derivative of the inside, or the second out over here, which would be, basically, this is a constant, so it goes to 0. So this goes down, so we have 4 times whatever is inside of that cubed, right? All multiplied by, again, or let me do a dot, the final inside, which is x squared plus 1. So we get 2x, right? So if we finalize this, we have 3 times, right? 3 times, and what was our inside here? It was 2 plus x squared plus 1 to the 4th squared, right? Times the derivative of the inside, which we had 4 times x squared plus 1 cubed. And then all of that was multiplied by 2x. So if we just try to make this look nicer, we get 24x, and then our first parentheses, which is 2 plus x squared plus 1 to the 4th, all squared, times our x squared plus 1 cubed. So I didn't change anything, I just rewrote it to make it look nicer. So what if we do this example right here? So we have 2 cotangent squared of pi of t plus 2. So let's rewrite this to make it look nicer. This is 2 and then cotangent of pi t plus 2, and then all that is squared. So our outside, really, our first outside is just 2 to something squared. So that's out, or let's highlight that, squared. So that's out number 1. And then inside of here, it looks like we have another out, which is cotangent of something, right? So that's out number 2. And then inside of cotangent, we have pi t plus 2. So that's our inside. It's our inside, right? So if we take the derivative of this, we get 4, because 2 times 2 is 4. Whatever is in there to the first, multiplied by the derivative of the inside of that. So this right here. So the derivative of cotangent is negative cosecant and then squared of something, right? And then all that is going to be multiplied by the final inside, which is pi of t plus 2. So the derivative of this is just pi. So that gives us multiplied by pi. So we finally finalize this. Let's move this pi over here to make that look nicer. We get 4 pi, and then our first inside was of cotangent of pi t plus 2, and that's the first, times our inside right here, which is negative cosecant squared of what was inside of our cotangent, which is pi t plus 2. all multiplied by, I'll move this over right here, all multiplied by our final inside derivative, which was pi, so we don't actually need that. So if we make this look nicer, this is just 4 pi, and then we got cotangent of pi t plus 2 times, or let's put the negative outside here for this negative, and just we have cosecant squared of pi t plus 2. So that's how you do the last one. So it's nice to label what's your first outside function, what's your second outside function, and then your inside function, and that you know that this second outside function will go into your first outside, and this your inside function will go in here, and that'll make life a lot easier when you're trying to do chain rule.